3x3 system just means I have 3 different equations and 3 different variables. So we've been dealing strictly in 2 equations, 2 variables. And so if you have 2 variables, you need 2 equations to be able to solve for both of them. If you have 3 variables, you need 3 equations. If we were to have 4 variables, we would need 4 equations to be able to solve for them. So you're going to see 3 equations for each one of the questions we're going to do today. And it just says when the solution to a system of equations in 3 variables is represented by a point. We'll do this a little bit later in the unit, but it's actually a 3-dimensional space that you would graph that in, but what they call it is an ordered triple. And all that means, it's just like you would write a point like x comma y, they just add z into the mix for the 3rd variable. So an ordered triple, whenever you write your answers, you can just write them, it's like a point with an extra coordinate in it is what it looks like. It's actually 3-dimensional. In terms of how we're going to do this, I'm going to walk you through elimination and I'm going to walk you through substitution, but you can actually use whichever one you like better. It's totally up to you, and you can use a combination of the 2. Maybe as you go through the problem, you'll see what I'm talking about in a second. But you got to eliminate or substitute for the same variable in both equations. So we're going to go through that first. We'll just do kind of an elimination example, and then I'm going to do a substitution example with you guys on the back. So you don't have to do this, but the first thing I always do is I just number the 3 lines, just like 1, 2, 3. And that way I can reference what I'm going to do with them. So what you want to do, just to start this out, you're going to pick 2 equations out of the 3, and you eliminate a variable. So we can pick any 2 of those. You've got 3 equations to pick from. You're going to pick 2 equations, and we're going to eliminate a variable. Now, if I'm being honest with you, I don't necessarily see one that is super easy compared to the others or anything like that. Does anybody have a preference? Like, do you want to go after X, Y, or Z? Doesn't matter. Well, if you were looking at that system and I said, let's eliminate a variable, what variable would you maybe go to for that? What do you think? She says Z. Let's do 2 and 3. Hey, yeah, actually, we could do that right away. I don't even have to manipulate anything. All right, so if I use equation 2 and equation 3, we can actually just copy those down. We don't have to eliminate anything. Or we don't have to multiply by anything because it'll just eliminate because those z's are already opposites. All right, now I'm just going to add the bottom line to the top line. So we got 6x's plus y equals 8. And I'll tell you right now, I did this with another class this morning, and they did something different. So there's a lot of different ways you could solve these, and we could still get to the same answer. Okay, now here's the key. You pick 2 equations, you eliminated, we decided to get rid of z. All right, so you pick 2 different equations. Okay, now this is important. You have to eliminate the same variable. You're going to pick 2 different equations, and you have to eliminate the same variable. So since we decided to get rid of z, when I pick these other 2 equations, I have to still get rid of z. All right, so you can't pick 2 and 3 again. So we could do 1 and 2 or 1 and 3. It's up to you guys. What do you want to do? Pick equation 1 and 3 or 1 and 2? Hunter, what do you want to do? You want to do 1 and 3? Okay. Would I have to manipulate either one of them to eliminate z? Which one? Yes. Okay. So I'm just going to copy the very first line. And if we have to go after z, I'm going to have to try and make it match, or I would recommend make it opposites with that first equation. So if I use 1 and 3, that third equation, you just have a 1 in front of the z. I'm just going to run a -4 through that third equation. And I just write that out in front because that's what I'm going to do. So everybody gets multiplied by -4. So this would be -20x minus 8y minus 4z, trying to make those z's opposites to get rid of them, and then minus 20. Now, I'd get negative 19, bless you, negative 19x. 2 minus 8 is going to be negative 6y, and 6 minus 20 is going to be negative 14. All right, so basically all we did, we had two equations that we worked on eliminating the same variable. The original problem, we had 3 equations, 3 variables. Now we have 2 equations, but with the same 2 variables, with x and y. So the second part of this is just to solve this like the systems that we've been solving. So I get negative 19x minus 6y equals negative 14. So basically, I went from 3 equations with 3 variables. Now we have 2 equations with 2 variables. You would just solve this like a normal system. Now, I would just say, actually, what we have set up here, if you like substitution better, it would be really easy to get y alone in that first equation. I would just subtract 6x. So if you prefer substitution, you could do that. If it's me and I see that same thing, that coefficient of 1, I would just run a 6 through this top equation and then cross the y's off like that. So I would have 36x plus 6y equals 48. If I do that, then I get negative 19x minus the 6y minus 14 here. The y's go, oh my goodness, what is that? 17x and 34. And then this is a nice number. I'm going to divide both sides by 17 real quick, and x will be 2. Once you get x, you just back up one, or whatever variable you get. In this case, we got x first. You just back up one step, and you can plug it into either one of these equations that we had for our 2x2 system, or you could, if you want to, you could plug it into one of these. I'm just going to try and grab the one that has the smallest coefficients. I'm going to go plug it in right there. So I'm going to take 6 times x, which now I know is 2, plus y equals 8. So I'm going to get 12 plus y equals 8. Just subtract the 12 real quick. Y is going to be negative 4. Once you have y and x, then you got to go back up to the original system, pick one of those 3 equations. Okay, I'm kind of far toward the bottom of the page here, so here's what I'm going to do. I'm going to copy the second equation that was in that original system, just because the coefficients are the smallest there. And I'm going to put in what we know x is, which is 2. And I know y is negative 4. So be careful with that, because that would be minus a negative if you're using that second equation. I'm going to end up with 6 minus z equals 3. I'm going to subtract 6 real quick here. So negative z is negative 3, so that means positive z is positive 3. Now, as long as you have all those, you're good to go. If you want to write it as the ordered triple, that just means the x-coordinate would be written first, the y would be written second, and the z would be written third. It's not terrible, but it's definitely time-consuming. Is anybody having a question? Okay, now I'm going to try one more with you that is just a basic introduction. This is with substitution versus elimination. Now I will tell you, like I have x by itself in this first equation because I got to show you both methods. If you don't like substitution when we go through this, this would be super easy to use elimination with. I'm just, you don't have to write this, but I would just write this above here. I'm going to write it above here. I would just subtract the 3y and add the z back to the other side and put that in kind of standard form real quick. So if you want to do that, if you like the elimination better, you can. I'm going to go ahead and use substitution on this one, but it's really easy to manipulate these equations if you have a preference for one or the other. So you can put all the variables on one side, plain numbers on the other, and use elimination if you like that better. What I'm going to do here is give you an example with substitution though. So you have one equation that's solved for one of the variables. What you're going to do is you're going to substitute what that variable equals into both of the other equations. And what will happen then, we'll have two equations. Once we do that substitution, those two equations will only have two of the variables, and it'll essentially get rid of the x in this case. So let me just write this real quick here. We've got 2, and then in place of the x, I'm just going to use parentheses because we're going to have to distribute a 2. And forgive, I feel like sometimes in these problems, you got to be real careful because I think a z can look like a 2 really easily. So just make sure you're trying to, I usually put like a little line through my z so I know it's a z. So I'm going to sub this into that second equation. This would be minus 5y minus z equals negative 2. And I would do that substitution. I'm going to grab a different color real quick. If I substitute it into that third equation, we have negative x. So I'm going to put a little set of parentheses. We'll distribute a negative. We'd have that 3y minus z plus 6 in place of the x plus y plus 2z equals 7. You don't have to do those both at once. That's just what I was doing there. So I'm going to move back, simplify this, just a little distributive property. Got 6y minus 2z plus 12 minus 5y minus z equals negative 2. Okay, now I know there's a big long side to that. So I've got a 6y minus 5y. I'm going to put those guys together. That would just be 1y. Now, you have a negative 2z, and down here I have another negative z. So if I subtract those, that would be minus 3z. And this is completely up to you, but usually what I do at this point is if there's any plain number on that side, I have a 12, I move that to the other side, just going to subtract it there. And this will look a little bit more like standard form, where we have all our variables on the left and that one number on the right. Okay, now I'm just going to do that with the other equation, just simplify that real quick. So I got to distribute a negative here. It's just going to change all your signs. So negative 3y plus z minus 6. Then you have a plus y plus 2z equals 7. Just going to go through, try and combine like terms. So let me see if I can grab my y's. I've got a negative 3y plus y. Put those guys together. This would be negative 2y. And then I'm going to grab my z's. I've got a z here and a 2z here, so 3 total. And I'm just going to kind of do what I did on that last equation. I got a plain number that's negative 6. I'm going to add that to the other side just to kind of set this up so it's in standard form. And we used some substitution there, but we went from 3 equations with 3 different letters. Now I've got 2 equations with just 2 letters. You don't have to stick with substitution. Like if you want to do it, you can. It would be easy to get y alone here and substitute if that's your preference. If it's me, I'm looking at this right now going, hey, I've got a positive 3z and a negative 3z. So I would literally, we don't even have to do anything. I'm just going to write this underneath here. So I've got the y minus 3z equals negative 14, and I can eliminate those z's right then and there. I don't have to do anything. I have negative 2y plus y would be negative y. We have 13 plus a negative 14 would be negative 1. So negative y equals negative 1, meaning positive y is going to be equal to positive 1. Once you have that, then you just back up one step and you start substituting it in. It doesn't matter which equation you want to use. I might just use this one because it has smaller coefficients there. I know y is 1, so 1 minus 3z equals negative 14. I'm going to subtract the 1. So we get negative 3z equals negative 15. And I'm just going to divide by negative 3 real quick. The negatives are going to cancel out there, so z is going to be positive 5. And then once you've got 2 of the variables, go back to the original system. And in this case, I would just go ahead, let me just use this first equation because that had x by itself. So I'm going to find x. I know I have 3 times y, which is 1, minus z, which is 5, and then plus 6. So you're just going to get 3 minus 5 plus 6, and x ends up being, let's see, 4. Once you have all three, if you want to just leave it like that, I'm totally fine with it. If you want to write that as an ordered triple, X would go first, so the 4. Y would go second, the 1, and Z would go last, which would be the 5. That would be an ordered triple. But as long as you show me each of the 3 variables somewhere in the paper, I'm completely fine with that. Is anybody having a question? It's not bad, but you can see it's time consuming. And I'm just going to warn you up front, it is so easy to make just like a tiny mistake that screws up the whole thing, and then you're going back trying to look in your work. I promise if I give you a question like this, the answer will be a nice number. Like it might be positive or negative, but I'm not going to give you any decimals or fractions for these kinds of systems. So that way you can kind of check as you go. If you're getting a weird answer, you'll know that maybe a little mistake was made. The last problem we're going to try here is a word problem. And so we have to set up the 3 equations. If you have 3 variables, you have to have 3 equations or you don't have enough information to solve for it. So this guy says a vending machine takes only nickels, dimes, and quarters. So just so we all have the same thing, I'm just going to let N be nickels, D be dimes, and Q will be quarters. Okay, now I've got 3 different variables, 3 different types of coins, so we got to get 3 equations out of this somehow. If we don't, then we don't have enough information. All right, it says we have 40 coins. I can get an equation right from that. If I have 40 coins, how could I translate that into an equation? Riley, what do you think? Perfect. N plus D plus Q equals 40. Nothing to do with their monetary value, just how many coins you've got. Okay, let's see what else. We have the value of the coins is $5.30. So I can get a full equation out of that. Can anybody tell me what the equation would be if you know that you've got nickels, dimes, and quarters and it's $5.30? Yeah. Perfect, perfect, perfect. Okay, you don't need the 0 in front of the D. I just like to do that to help line stuff up. Okay, now, the trickiest question of all, of course. Many good colors here. Let's see. Twice as many dimes as quarters. Does anybody want to, how do I write twice as many dimes? Cambry, what do you think? Exactly, exactly. I'm just going to put the D first, but 2Q is equal to D. Remember, this is always weird. Whenever you have that as many as, and I'm far, far away from this. Okay, the twice goes by the word farther away from it. So twice as many dimes as quarters. If I told you like, okay, we have 4 quarters, I have twice as many dimes, then I would have 8 dimes. So you got to multiply the number of quarters by the 2. That's what's going on there. Now, what I would tell you on this question, you'll notice the third equation doesn't involve all 3 variables. It doesn't have to. You just have to have 3 equations. Now, what I would tell you to do here, you could set this up for elimination if you wanted to. You could move the 2Q and put 0N and put 0. I would tell you in this particular case, what I would do is substitution though, because I can just take what D is equal to, and I could sub it in to both of the other 2 equations. That'll get D out of those 2 equations, and then we'll just have nickels and quarters to work with here. So once you set up the word problems, a lot of the time they're not actually as bad as some of the more straightforward systems, because one of the equations might be like a little bitty one like this. So if you look at that original equation that I wrote down, I'm going to write nickels. Instead of plus dimes, though, just sub in the 2 times the quarters plus the quarters equals 40. And then if you can simplify a little bit, this would just be nickels plus 3 times the number of quarters would be equal to 40. There's one equation. So I went with 3 equations. I had 3 variables. We're going to go for 2 with 2. Let me make this a little bit bigger. I feel like it's so small. I'm going to substitute that 2Q into that other lovely equation up there. So if you don't like dealing with the decimals, you could take that second equation and multiply everything by 100 if you're not into the decimals. Doesn't really bother me one way or the other, so I'm just going to stick with it. But if you don't like it, just take that second line, multiply everything by 100, and then you can work with plain numbers. In place of the dimes there, I'm going to put 2q again, little substitution, and I'm just writing the rest of the equation out here. Now, if I would take 0.10, or like a dime, multiplied by 2, it would look like 20 cents instead of 10 cents. I'm just multiplying that by 2. Plus the 0.25q, 530 here. And we can combine the terms with the q's. So you have 0.05n, 0.20 and 0.25 would be like 20 cents and 25 cents. So it'd look like 45 cents in front of your q's, 530. And here is your second equation. So we went with 3 equations, 3 variables. Now we have 2 equations with the same 2 variables. This, again, is kind of up to you. It's like a creativity thing. I think anybody could solve these in different ways. We get the same answer. If you like substitution, that first equation we wrote, we could just subtract 3q and substitute if you want. I look at that and I think, okay, this just has a coefficient of 1 in front of the n, so I just usually use elimination, but you can do either one. It's completely up to you. I would just go through and multiply this line by negative 0.05, and I'm just going to write it underneath here. So it'd be negative 0.05n. If you do, it's like 5 cents times 3, so this would be negative 0.15q. And if you do 0.05 times 40, you're going to get, sorry, negative 0.05 times 40, this is going to be negative 2. I'm going to make it look like $2 just to line that up to make the subtraction easier for myself. The nickels would go there. I'm eliminating those. You get 0.3 or 0.30 times your number of quarters equals 330. And then again, you should not get a decimal or a fraction if you're talking about a number of coins. We can't have part of a coin. So my quarters there are just going to be 11 when you divide that. Then a lot of times if you have a word problem, going back and finding the other variables might be a little bit quicker. So 11 here, all I have to do to get my number of dimes is just multiply that by 2. So my number of dimes is going to be 22. And then the original first equation we wrote, nickels plus dimes plus quarters, 40 coins, right there I've got 11 quarters, 22 dimes, so that'd be 33 coins total so far. So the nickels have to fill out the rest of that. So then you would have to have 7 nickels. And if you want to go back and check any of these, then you can. And I'm trying to think if there's anything else. On this situation, we would just write the 3 variables. If you do have a problem where you don't have X, Y, and Z, the ordered triple can be written in alphabetical order. So if I had to write this as an ordered triple and I had dimes, nickels, quarters, you would write them in that format, just alphabetical order if you don't have X, Y, Z. They're just, if they use different variables in a question, alphabetical order works just the same.